Back. So problems 0.4. Let's start with question 1, which says we should perform the indicated operations and simplify. So the indicated operation here is addition. Add up these two expressions basically. All right. So again, we start by opening up our brackets and then collecting like terms. Plus 2 plus 3x plus 2y minus 5. So 8x and 3x are like terms, so we add them up. 8x plus 3x gives us 11x. Negative 4y and 2y are also like terms, so we add them up. Negative 4 plus 2 is negative 2, negative 2y, and 2 and 5 are also constant terms, so they are like terms. 2 minus 5 becomes minus 3. Okay, so that's sum there. Okay, let's take another example. This example says, this is number 5, square root of a plus 2 times square root of 3b minus square root of c minus square root of c minus 3 root 3b. Okay, so again, first things first, open up your brackets by distributing this negative sign to each term in the bracket. So it's a square root of a plus 2 square root of 3b minus square root of c plus, right? Because minus becomes a plus, 3 square root of 3b. Then we add up like terms, all right? Now, a is alone. There's no other a variable a in any of the terms. So it just remains the same, square root of a plus square root of 3b is in this term, and square root of 3b is also in this term. All right. So we can add up their coefficients. 2 square root of 3b plus 3 square root of 3b becomes 5 square root of 3b. Okay, so C3b like apples or bananas. So it's like 2 bananas plus 3 bananas, which is 5 bananas, basically. All right, just see it as the variable there in that term. Minus square root of c, since there is no other like term. Okay, and that is our final. Okay, let's take this other example, number 15 of the same 0.4. So it says 2 times the bracket, 3 bracket, 3 again, bracket, x squared plus 2 minus 2 bracket, x squared minus 5, and then the 2 brackets. Okay, basically. So we need to carry out the given indicated operations and simplify. So in order to do this, I would like us to start with the inner brackets and then we go out. All right. So start by simplifying everything in this bracket. Then we move to this other bracket before we move to the most outermost bracket. So we look at these terms. So we carry out constant multiplication on each of these terms first. Multiply the 3 by each term in the bracket and the 2 by each term in the bracket. So we get a 2 outside, 3 outside, and then 3 times x squared is a 3x squared. 3 times 2 is 6. Okay, minus 2 times x to the 5 is 2x to the 5. 2 times negative 5 is negative 10. Okay, and then we have our 2 brackets there. Next, we evaluate each of these small brackets. right? Carry out this operation of subtraction in this bracket, right? By distributing this negative sign first to each term in the bracket. So we still have our 2 big bracket, 3 big bracket. So this becomes 3x squared plus 6 minus 2x to the 5. Minus becomes plus 10 brackets. Okay. Then we add and subtract like terms. So looking at these, this doesn't have any like term. 6 has a like term, which is 10. And this also doesn't have any like term. So it becomes 2 big bracket, 3 big bracket, 3x squared minus 2x to the 5 plus 16, adding like terms. Okay, next we evaluate this constant multiplication by 3. So by multiplying 3 with each term in the bracket there, so 2 big bracket, 3 times 3x squared becomes a 9x squared minus 3 times minus 2x to the 5 becomes a 15x to the 5. 3 times 16, right? 3 times 16 will be, 3 times 6 is 18, and 3 times 6 is 18, 8 carry 1, 3 times 1 is 3 plus 1, 4 for the 8, so it's a plus for the 8 there. Okay, then lastly, we then multiply in the 2. So the whole thing becomes 9 times 2, 18x squared minus 2 times 15, 30x to the 5 plus 2 times 48, 2 times 8, 16, 6 carry 1, 2 times 4, 8 plus the 1, 96. Okay, and that's the final simplified form for that expression, basically. Okay, let's take more examples. Taking more examples. Okay, so if we look at number 19, okay, here we are multiplying. Number 19, we are multiplying these expressions. So it's 19 there, which is x plus 4 times x plus 4 times x. So it's x plus 4 times x plus 5. So again, we are multiplying each term in the first bracket by every other term in the second bracket, basically. Okay, that's how it works. So it's going to be equal to x times x squared. I already showed you how x times x is x squared by your laws of exponents, all right? X times x, bases are the same at their powers. It becomes x to the 1 plus 1, which is x squared. Okay, this is how you multiply using your laws of exponents that we saw in the previous sections. Okay, x squared, x times 5, positive 5x plus 4 times x, 4x, 4 times 5 plus 20. Then we look out for like terms and add them up. These are the only 2 like terms in the expression. And it becomes plus 9x plus 20. Okay, so that's that. Then number 27. Number 27. 27 says we should multiply 7 minus x all squared. Okay, so 7 minus x all squared simply means 7 minus x times itself. Okay, that's what 7 minus x squared means. 7 minus x times 7 minus x. So therefore, 7 minus x cubed will mean multiply 7 minus x by itself 3 times. Okay, 3 times. And 7 minus x to the 4, multiply it by itself 4 times, and so on. Okay, so take note of those kinds of exponents. Okay, so that's what this simply means. So again, we carry out the same process. 7 times 7 is 49. 7 times minus x, all right, it's minus 7x. Minus x times 7 is minus 7x. Minus x times minus x is positive x squared, because minus times minus becomes plus. Always read a term together with its sign, very important. After this, we look out for like terms, combine them. So this becomes 49 minus 14x plus x squared. And that's the final expanded form for that expression. Okay. Now let's take some division examples. Let's take some division examples. So division examples, we have number 46. So number 46 says we should divide 2x cubed minus 7x plus 4 divided by x. Okay, so we can just divide this by distributing the x basically to each term in the numerator, right? And we get our 2x to the 3 minus 1, laws of exponents, 7x to the 1 minus 1, minus 4x to the minus 1. So our answer will be 2x squared minus 7 minus 4x to the minus 1. Okay, which is then our answer there. Okay, number 47 is the same as 48. All right. So I'd like us to then look at this other example before we take some long division examples. Let's quickly look at this one. So this one says it's number 37 actually. Okay, it looks quite challenging and nice. T bracket, remember bracket represents multiplication, okay? Don't forget that bracket stands for multiplication. Times t minus 4 plus 5 bracket 3t bracket t minus 7. Basically. Okay, and that's it. So we want to perform the indicated operation and simplify. Okay, so looking at this, the best way to go about this is to, first of all, perform the operations on this term separately and the operations on this term separately. Then we multiply in the t. Okay, so it becomes a t. Okay, I'd like to just take out this line to give me more space. It becomes t outside the big bracket. Okay, I'd like to big bracket, perform this product here, multiplying in these two brackets. So t times t is a t squared. T times minus 4 is a minus 4t. 2 times t is a positive 2t. And 2 times minus 4 is minus 8. All right. So plus 5 is outside. Then I also do this, everything in this bracket there, right? Multiply 3t by each term in the bracket. So it's a 3t times 3t, which is 3t squared, 3t times minus 7, which is a minus 21t, basically. Okay, so that's how the brackets then look like. Next, I open up the brackets again by multiplying in the constants, the 3 and the 5. So t is still outside. Multiply in the 3, we get 3 times t squared, 3t squared. 3 times. Now, I can add up these two, right? Because they are like terms, okay? In fact, let me take that step first by collecting like terms first. So 3 is still outside. I have my t squared there. Combine these two, 2t minus 4t plus 2t is a minus 2t minus 8 plus 5 times 3t squared minus 21t. Okay, then I bring in my constants, the 3 and the 5. I multiply in 3 and 5. 3 times t squared is 3t squared. 3 times negative 2 is negative 6t. 3 times negative 8 is negative 24, right? Plus, okay, so I'm multiplying in, so I can remove the brackets. 5 times 3t squared is 15t squared. 5 times minus 21. Okay, so 5 times 21 should be 105 minus 105t. Okay, that's it. I can combine like terms first before I bring in my t, or I bring in my t, then combine like terms, the same thing. Okay, I would like to bring in my t first. So I multiply the t in. I get t times 3t squared, 3t cubed, minus t times 6t, 6t squared, minus t times 24, negative 24t, plus t times 15t is 15t cubed, and 10, 105t, negative 105t times t is negative 105t squared. Okay, then I collect like terms. I see that t cubed and t cubed are contained in these terms, so they are like terms. If you combine them, you get 18t cubed. Then t squared is in this term and also in this term. If you combine them, you get negative 111t squared minus 111t squared. And t is standing alone, so we just write it minus 24t. Okay, and that is our final answer. Okay, so that's the simplified form of this, and I'd like to see all these steps if in the case of an assessment, each of these steps are quite necessary. Okay, let's look at some division examples now. Let's look at a couple of long division examples. Okay, so the first one I'd like us to look at is x squared minus 5x plus 4 divided by x minus 4. Okay, divided by x minus 4. So we want to carry out division of these two expressions. This expression divided by this one. And the only way is to do long division. So as I said, this is my dividend and the divisor, basically dividend and divisor. All right, and I need quotient and remainder to make up my answer. So again, I have my long division symbol. wherein I put my divisor there and my dividend over here. 5x plus 4. Okay, so now I am ready to divide. So the process is still the same. The procedure is the same. First term in the dividend divided by first term in the divisor. Put your answer there in the quotient area. Take that quotient, multiply each term in the divisor, put the answer there, subtract these two to get the new dividend. Repeat the process until you can no longer divide. Okay, repeat the process until you can no longer divide, basically. So, x squared then divided by x is x. X times x is x squared. I already showed you how this division works. Okay, x squared divided by x is x to the 2 minus 1 by our loss of exponents, which is x. Okay, I don't need to be showing you this all the time. Use your loss of exponents every time. X times x is x squared. X times negative 4 is negative 4x. All right. So I just need to add a plus 0 there so that this term corresponds to this one, this corresponds to this one, and then this one should correspond to the 0. Okay. Then I am ready to subtract term by term. So x squared minus x squared is 0. As I told you in the first few examples, the first terms always vanish every time we carry out subtraction, all right? Minus 5x minus 4x. This is a typical example of the reason why it's necessary for you to put this bracket and this negative sign. So imagine that you don't have this, okay? A typical mistake to make that I've seen students make all through the years is just to say minus 5x minus 4x, and then they get their minus 9x, which is wrong, okay? And forget about the minus sign, which is supposed to be here. So it's important to put it so that you don't forget it. Okay, so it becomes a minus 5x minus 4x, which is practically a minus 5x minus 4x, which is minus 5x plus 4x basically, which is minus x and not minus 9x. Okay, so it's important for you to always put your negative sign there. So it's a minus x, okay, 4 minus 0 is a positive 4. Okay, so we have our new dividend. We are ready to divide again. So minus x divided by x, all right? Look at that, minus x divided by x. This becomes a minus x to the 1 minus 1, which is minus x to the 0, which is minus 1. Okay, so it's a minus 1. 1 times, okay, minus 1. Minus 1 times x. Okay, another common mistake to make is to say 1 times x instead of minus 1 times x. Always read a term together with its sign. Minus 1 times x is a minus x, and minus 1 times minus 4 is a positive 4, minus minus. Then we are ready to subtract again. Carry out minus subtraction. We get a minus x minus x, which is 0. Okay, and a 4 minus 4, all right, which is equally 0. Okay, so our remainder is just 0. We don't have any remainder here. So therefore, our answer will be, okay, our answer, we could take out this and write our answer. So our answer will be what? Write it there. Answer will be then quotient, okay, just quotient, since the remainder is 0. Your answer is just x minus 1, basically. Okay, so that's that. Now let's take another example. Let's take more examples to get this really clear and right. Okay, so if we have to take another example, I would like to, so this example was number 50 of problems 0.4. I'd like us to take number 52 of 0.4. It says divide x to the 4 plus 3x squared plus 2 by x plus 1. Okay, divide these two expressions. Now notice something. Notice that our expression here is not complete. All right, by not complete, I mean all the terms that should be in a polynomial of degree 4 are not there. Okay, now in a quadratic, for instance, a polynomial of degree 2, it's supposed to be x squared, and then we get a term in x, ax squared, bx plus a constant c. Of degree 3, it should be ax cubed plus bx squared plus cx plus d. Of degree 4, it should be ax to the 4 plus bx cubed plus cx squared plus dx plus e, basically, right? We should have 4, 3, 2, 1, then 0. Okay, powers of x should decrease in that order. But if you look at this, we only have 4, 2, and 0. Okay, so 3 and 1 are missing. All right. Now, normally for a student who is very versed with long division, you can divide without necessarily including the powers 3 and 1. Okay, but to accommodate everyone, I'll advise you always then rewrite this as x to the 4 plus 3, 0 plus 0x cubed plus 3x squared plus 0x plus 2. All right? You should write this in this manner just to not get confused during your division process. Okay, so that's it. We are then ready to divide. Okay, so our divisor is there, x plus 1, and our dividend will be here. Our dividend will be x to the 4 plus 0x cubed plus 3x squared plus 0x plus 2. Okay, just to, the zeros are just there to make this a complete polynomial of degree 4, having all its terms, so that when you want to subtract, you don't get confused and mix up the terms. Okay, this is just to make your life easy. It's not compulsory. You can still do it using the polynomial the way it's been given if you are sure of what you are doing. All right, so now we are ready to divide. X to the 4 divided by x is x to the 3. Then we multiply this by each term in the divisor. X to the 3 times x is x to the 4. X to the 3 times 1 is x to the 3. Okay, so you see why I needed to add up this. Okay, so that when you want to subtract, you have to x to the 3, x to the 3 to subtract with as like terms. Okay, so that's done. We don't have any terms for x squared, x, and the constant term. So I just add the zeros there, 0x squared plus 0x plus 0, just to make my subtraction easy and not confusing. Okay, so I'm ready to subtract now. X to the 4 minus x to the 4 is 0. As I said, first terms always vanish. 0x cubed minus x cubed is a minus x cubed. 3x squared minus 0x squared is a plus 3x squared. 0x to minus 0x is 0x, and 2 minus 0 is 2. Now I have a new dividend. I'm ready to divide again. Minus x cubed divided by minus x is a minus x squared by my laws of exponents. Minus x squared times x is a minus x cubed. Minus x squared times 1 is a minus x squared, right? Then I just include the 0x plus 0 just to make subtraction not confusing. And there I have it. Subtract. First terms always vanish. 3x squared minus x squared, right? It's like a 3x squared plus x squared, which is 4x squared. And 0 minus 0x is a 0x. 2 minus 0 is a positive 2. Okay, my highest power of x in my dividend is x squared, higher than this one, so I can still divide. 4x squared divided by x is a 4x. 4x times x is 4x squared. 4x times 1 is positive 4x. Okay, and then I just add the plus 0 there to make subtraction easy. Okay, let's take the next page. 4x squared plus 0x plus 2. So it was 4x squared plus 0x plus 2. And underneath was 4x squared plus 4x plus 0. Okay. Underneath was 4x squared plus 4x plus 0. Okay, and we were about to subtract this. And we had some terms up here, and then we had our thing. Remember that there are terms here. All right. We had our thing, which was, what's our divisor, x plus 1. Then we had x cubed minus x squared plus 4x. X cubed minus x squared plus 4x. X cubed minus x squared plus 4x. And we have x plus 1 there. Okay, so we subtract and we get a 0 there. 0x minus 4x is a minus 4x plus 2. Okay, so again, x powers are the same, we can still divide. So minus 4x divided by x is a minus 4. Minus 4 times x is a, this is cubed, please. Minus 4 times x is minus 4x. Minus 4 times 1 is minus 4. Again, I am ready to subtract. Minus 4x minus minus 4x is 0. 2 minus minus 4 is like 2 plus 4, which is 6. Power of x there is 0. Power of x there is 1. We can no longer divide because the highest power of x in here is lower than the highest power of x there. So 6 is then our remainder. So our answer will be quotient, which is x cubed minus x squared plus 4x minus 4 plus remainder over divisor. Okay, and that is our answer by long division. That's our answer there by long division. Okay, let's take another long division, good long division example. This is number 53. 53. And it says divide x cubed by x plus 2. Okay, x cubed divided by x plus 2. Now, again, I would like to write this as in its complete form. x cubed plus 0x squared plus 0x plus 0. Okay, I like to write it in its complete form. Then I put everything in my long division symbol. My divisor is usually there, and my dividend is over here. 0x squared plus 0x plus 0. Okay, I'm ready to divide. X cubed divided by x squared, x is x squared. All right. Take that answer, multiply each term in the divisor. Write it down here and subtract. Underneath the dividend and subtract. So x squared times x is x cubed. X squared times 2 is 2x. All right. Again, I just need to write the zeros there to make subtraction easy and not confusing. So x cubed minus x cubed, first terms always vanish. 0x squared minus 2x squared is a negative 2x. This is x squared. Negative 2x squared. 0x minus 0x is a 0x plus 0. Okay, I am ready to divide again because I have x here and I have x here. This is x squared, please. Okay, I have x squared here higher than the power of x there, which is 1. So I can still divide. So minus 2x squared divided by x. All right. So again, as I showed you, minus 2x squared divided by x. So minus 2 stays aside. I combine these guys using my laws of exponents. X to the 2 minus 1, which is minus 2, stays aside. This guy becomes that. That's how I got my minus 2x. I keep showing you this, right? Because many people don't know how. We just get this. So it's a negative 2x divided by x. As I just showed you, it's a minus 2x. Minus 2x times x is minus 2x squared. So again, minus 2x times x, okay? How did we get the answer to be minus 2x squared? Laws of exponents. Law 1, keep my minus 2 aside, all right? X times x, okay? Same basis, add their powers. So it becomes minus 2 aside, x to the 1 plus 1, which is minus 2x squared. That's how I got this minus 2x squared here, right? That's how I got to the minus 2x squared there, basically. Then we're still multiplying. Minus 2x times 2 becomes a minus 4x. So I just include my 0 there to make subtraction easy. Minus 2x squared minus 2x squared. First terms always vanish during subtraction. 0x minus 4x. It's like 0x plus 4x, which is positive 4x plus 0. Now I have x there, I can still divide, all right? So 4x divided by x, it's a 4 by the same method I just showed you. 4 times x is 4x. 4 times 2 is 8. Again, I can easily subtract. So it's a 4x minus 4x is 0. And 0 minus 8 is a negative 8. No x here, x there, I can no longer divide. All right. So my answer will be quotient, which is all of this part. All right. So it's x squared minus 2x plus 4 plus remainder. So remainder is a minus 8 over divisor x plus 2. And that is my solution for that operation by long division. Okay, so that's that. Thank you so much. I think we'll do a few more long division examples in the next video.